fourth root of what? 15 x cubed y. And I don't think anything simplifies and we're good to go. Don't forget to write the proper index. Don't forget it. Because if you forget the fourth root, now it's the square root, and now we don't have it right. Okay? So here I have the cube root times the cube root. Let's write it as all as one cube root. So I have the cube root of 3b over 20. And don't forget that root. Okay? Don't forget that root. All right. Now you're going, well, this time it would make sense to think of this as the square root of 75 divided by 3, which is the square root of 25, which is 5. Still good? Okay. All right. Super easy problem. I try to make it... Oh, I forgot to do these two problems, didn't I? Okay, we'll do it here in a second. What's cube root of 8? 2. What's cube root of 27? 2/3. Done. All right, let me hit pause. Continuing on. Here we go. Square root of 50. Okay, let's make sure we know how to do this. Now, guys, I'm going to do it slightly different than what your algebra teachers did. Look for perfect square. When I say perfect square, like 4, 9, 25. Oh, wait, there's a perfect square in 50. What is it?
25.
Now, so it's 25 times 2. Yes? Now, think about it. It's still underneath the radical. You don't need to write it, but it's still... What's square root of 25? So I circle a perfect square and say 5 square root of 2. Done. Now, I don't know if that's how your Algebra 1 teachers did it. A lot of teachers I see break it. They take the 25 and they write 5 and 5 and you circle a pair. Well, or just what's square root of 25? So when you see the cube root of 24, you're looking for perfect cubes. Look, 8 times 3. Circle it. What's the cube root? You're underneath the radical cube root still. What's the cube root of 8? 2. I don't know the cube root of 3, so I write cube root of 3. Done. You guys don't write 3 2s, do you, and circle a triple of 2s, do you? Cole, is that what you guys did in the past? It's okay. Yeah? Okay. Not wrong. I think this is more efficient for you guys. Square root of 98. Well, it's even, so what times what? 2 times... Oh, good. You're going to stop, aren't you, Cole?
No.
Yeah. You're going to circle the 49, aren't you, Cole?
Oh, yeah.
Why? He has no idea. Why the heck are we circling the square root of 49? Seth?
Because it goes to 7.
The square root of 49, 7. So 7 square root of 2. Again, you're not going to see me breaking it up and circling pairs. If you want to do that, that's fine. Okay? I'm going to teach you like a man. All right, here we go. Cube root of 50, or a woman. There we go. Equal here. All right? Cube root of 54. What times what? 20. Ooh. What? Ooh, why am I oohing? Ooh. I like the 27. Minachi, why do I like the 27?
Because it's the perfect cube.
Yeah, what's the cube root of 27, guys? 3. Don't know the cube root of 2, so I'm going to write cube root of 2. Here we go. Now we're cooking with Pinot. All right, just for fun. Look at this silliness. Let's just do it the other way. Look at this silliness. Do you really want to go 27 times 2, and then 9 times 3, and then 3 times 3, and you want to do that? Do you really want to do that? I'd mess up. Okay. I understand it's fourth root, so let's just start with something simple and see if things start falling together for us. Anybody got a factor of 243?
81, 30, 17.
Oh my goodness. Cole's jumping all in. Why is he all in? I'm oohing. Ooh. Why am I oohing right now?
81 is the 3 is the fourth root of 81.
3 is the fourth root of 81. 3 times 3, 9, 2. So what's the fourth root of 81? 3. Okay, now come off to leave some space. Fourth root of 3, right? Leave some space. Why? Why am I leaving some space? Because we still need to look and check these variables. Can't I take the fourth root of x to the fifth? Yeah, so it would be, there's x, isn't x to the fifth, just to give you a visual, isn't that x to the fourth times x? And the fourth root of x to the fourth is x with a leftover x. Agree? What about the fourth root of y cubed? Can't do anything with it, so leave it underneath the radical. Bam. So we just did this one basically. What's the fourth root of 81? 3. So we don't even need to break it apart. Fourth root of 81 is 3. Then what about the z's? What do you think? Yoder, what do you think about the z's? So how would I take the fourth root of z to the 11th? So what you do is think how many z to the fourths you have.
8, 3.
So 8 and 3, but how many? So what's the fourth root of z to the 8th?
2.
Yeah, so z squared. Leftover fourth root of z to the third. Nice. Nice. And that's in perfect. We doing okay? Okay. Here's what I would do. Look and see. I have a radical over a radical. Can I, are they the same root? Yes. Can I just simplify that real quick? Let's do it in our head. What's the square root of 50 over the square root of 2? The square root of 25, which is 5. So let's rewrite this as 5 square root x over 2. I'm good. You guys good? Question? Okay. Okay, now this is what I would do. Say we have fourth root over fourth root. So let's think of this as one radical, and then look at this. Wouldn't this a raised to the negative 1 be moved to the top and have a to the fourth? And then b to the 6 over b cubed is b to the third, right? So first of all, let's break down the fourth root of 32. I'll write it right above. What times what gives me 32? 8 times 4, but I don't like that. Because neither one of those are a fourth root, Genevieve. You're not wrong. 16 and 2. You knew it as soon as you said it? Yeah. It's okay. I said your name, so it's on the video forever. Okay, so the fourth root of 16 is what, guys? 2 times the 2 out in front gives me 4. I'm going to leave a little bit of space just in case. Fourth root of, what do I have left over? 2. Okay, then we're in our head we go, okay, there's, the fourth root of a to the fourth would become a, but the fourth root of b cubed would stay b cubed. Questions? Yes.
I get how you put the a to the fourth up here, but what happened to the b cubed to the bottom?
Okay, so look. What's b to the 6th over b cubed? B cubed. So I did not. I simplified it, and then I can't take the fourth root of b cubed, so it stays underneath the radical. You follow me?
Yeah.
Okay, good question. Other questions? Okay, let's keep it going. All right. So here, first of all, what's 10 over 2? 5. So 5. And let's simplify it. Cube root. Well, what's 80 divided by 5? 16, isn't it? Yeah, 16. Okay, well, let me erase this. So it's 16. And then let's do this. Follow me. Shouldn't we move these two down here? So I'd have 16 over x to the 5th and a y in the numerator. I haven't simplified the radical at all yet. Besides just, I guess I have simplified, excuse me. I haven't taken out yet. 80 over 5 is 16. Y in the numerator, x to the 5th in the denominator. But here we go. What's the cube root 16? I think we could break that down, couldn't we? Yeah, can't we go 8 and 2? Circle the 8. What's the cube root of 8? Times the 5 in front gives me, so we have 10. Cube root of what's left over? A 2y. And then do this. All over. I should have wrote it like that at the beginning. What's the cube root of x to the 5th? X cube root x squared. Am I right? Okay, now here's your first time being introduced to this possibly. When we simplify, and we got a whole lesson devoted to this, but here's the exposure to it. I'm not okay with that answer still. Because you are not allowed to have a radical in the denominator. Simplified radical form doesn't allow to have a denominator. So what we do is, and I got a whole lesson devoted to it, I'm just exposing you to it first time. It's called you rationalize the denominator. Have you heard that before? Okay, this is what I would multiply by. I'm going to multiply by 1. I'm going to multiply both the numerator and denominator by the cube root of x. I'm going to multiply by the cube root of x. Mr. Dice, why are you doing that? Because look, first of all, I haven't changed the problem because I multiplied it by 1. Cube root of x over cube root of x is 1. Agree? Guys, what's the cube root of x squared times the cube root of x? The cube root of x cubed. And what is the cube root of x cubed? X. So my denominator becomes x squared. You're going, how'd you get x squared? Follow my cursor. The cube root of x squared times the cube root of x is x times this x gives me x squared. In my numerator, it would become 10 cube root of 2xy. That is in simplified radical form. Okay? This is called rationalizing the denominator. We'll continue working with that, but I want to expose you to it. All right, let's knock this one out quickly. What's the 7th root of q to the 17th? Well, how many 7s are in q to the 17th? 2. Q squared with how many left over?
3.
So leave some space and write 7th root of q cubed. How many 7s are in 40? 5. So r to the 5th, remainder r to the 5th, right? 35 plus 5. And then how many 7s are in s to the 7th? Just 1. Nothing left over. Don't forget to write the index, the 7th root. You guys doing okay?
Yeah.
All right, let's keep it going. All right. You can add like radicals, just like you can add like terms. So look up here. 2 square root 3 plus 3 square root 2, they're not like radicals. But look at this one. 2 cube root 2 plus 3 cube root 2. See how they're like radicals? So look up here. What's 2 of them plus 3 of them? 5 of them. But they have to be like. So here we go. I have 5 square root of 15 plus 2 square root of 15. Do I have like radicals? Yes. What's 5 of them plus 2 of them? 7 of them. Look here at 17. I have cube root 2y, cube root 2y. What's 9 minus 15 of them? Negative 6 cube root 2y's. Now be careful here. Follow me. Here, here, and here are like radicals. 10 square root of 2 minus 3 square root of 2, which is 7, plus 1 gives me 8 square root of 2. But that plus 7 is not like, so it has to be, it's just like x's and y's. You can't combine them. We doing okay? All right, keep it going. Flip your page over. So now if I say simplify, you're going, well, Mr. Dice, none of these are like radicals. They are not yet. Doesn't 27, isn't that 9 times 3? What's the square root of 9, guys?
3.
Times the 3 out in front gives me 9 square root of 3. I can't simplify 7 square root of 3, so 9 square root of 3 minus 7 square root of 3 minus, doesn't 12 break down into 4 times 3? What's the square root of 4? 2 square root 3. Now, they're all like radicals. Question, what's 9 minus 7? 2. What's 2 minus 2? How do I write 0 square root of 3? 0. Don't write 0 square root of 3. You would never write 0x. Same thing. We doing okay? Everybody stand up for a second. You're tired. You guys tired? All right, take a seat. Continuing on. Okay, I don't have like cube roots yet, but I think 16, we know that breaks down. We know 16 is what times what? Yeah, don't say 4 and 4. Don't care about that one. 8 and 2. Why do I care about that? Because 8 is a perfect cubed. What's the cube root of 8? 2 cube root of 2a plus, what's 54? 27 times 2, isn't it? What's the cube root of 27? 3 times 4 gives me 12 cube root of 2a. Hey, same cube root. So now what's 2 of them plus 12 of them? 14 of them, which is 14 cube root of 2a. We doing okay? Okay. Now, careful here. Let's break it down. I do think there's a 4th root in 32. Isn't 32 16 times 2? And let's think about it. Isn't 16 2 times 2 times 2 times 2? So what's the 4th root of 16? 2, 4th root of 2. Plus, again, isn't 32 16 times 2? But now, what's the square root of 16? 4 square root 2. Look up here. These are not like radicals. Y'all with me? This is your answer, though, because it's in simplified radical form. All right, so common denominator, got to have it. These are the same thing. I like writing it like this, but I want you to understand this means 3/5 square root of 3, same thing as 3 square root of 3 over 5. Okay? So, question. I have a like radical, agree? So let's break down 12. You guys probably got this down to an art now. What's the square root of 12 break down into? What's the answer? Just tell me the answer. So you're doing it in your head. Plus, what's square root of 12? 2 square root 3, isn't it? Because it's 4 times 3, and what's square root of 4? 3. So now look, same denominator. What's 4 square root of 3 plus 2 square root of 3? 6 square root of 3 all over 3. Oh, wait a minute. Isn't 6 divided by 3 2 square root 3? Question. Look up on the screen. I see, every now and then I see one of you guys trying to be a knucklehead. You're not good at it. Don't be knuckleheads. You're good at being good students. Okay, you're better at that. Don't think you can cancel here. That's not 3. That's the what? Square root of 3. If you type that in your calculator, it's 1 point something. Okay? So don't try think you can cancel here unless it's both of them were the square root of 3. All right? So let's see what we can do here. Well, 75 is 25 times 3. The square root of 25 is what, guys? 5 square root of 3 over 9 minus square root of 3 over 2. I'm going, yes, I have like radicals, but I don't have what? Common denominator, which needs to be what? 18. So let's see here. Let's go 18 and 9 times 2. So 5 times 2 would be 10 square root 3 minus 2 times 9 gives me 18. So 9 square root 3. So now question, what's 10 square root of 3 minus 9 square root 3? 1 square root 3, which we're going to write as the square root of 3 over 18. Agree? But then hold on. Can I go 3 over 18 gives me 1/6? No, because that's not 3. That's what? Square root of 3. Good. My younger students, like maybe not in honors, I always tell them the radical is like a force field. You can't attack the force field. You can't penetrate it. Leave it alone. Okay, I don't think the cube root of 5x simplifies. So I'm going to rewrite that cube root as the cube root of 5x. But I do think the cube root of 27 is what, guys? 3 plus 4 cube root 5x. Okay, now we can do this in our head. What's common denominator? 3. So what would this become? 12 plus 1. 13 cube root 5x all over 3. Right? I'm good with it. Bam. Okay, you guys getting that down? All right. So follow directions. That's not bad because it's just evens. It says give an exact answer, which is in simplified radical form, and then plug it in your calculator rounded to the nearest tenth. Cool? Okay. You guys are tired.